Hello, welcome back. This is Mr. Wakefield here. We're moving on to section 1.6. We will not be doing section 1.5, so that's why you're seeing 1.6 here. We already learned how to do linear equations. We reviewed that in the last video as a part of that discussion. And then what we actually did in the last video was quadratic equations. So we've done those. Those videos, those equations, linear and quadratic, they're the ones where you have polynomials on both sides of the equation, and then it just matters what the biggest exponent is. Okay, so now that we've learned how to do those types of equations, we're going to see those again as a part of the equations we see moving forward here in this section. But we have three different types of equations that we're going to be seeing in this section. The first one is equations with rational expressions. What that basically means right there, rational expressions, is it's when you have a fraction with a polynomial on the top and bottom. Okay, that's all that is. Okay, so basically this is fraction equations that we're dealing with here. And there's different methods to solving fraction equations depending on what you got. But the one method that basically works all the time, whether it's a big fraction equation or a smaller one, is the one where you start right out by getting rid of the fractions right away. You clear them out, and the way to do that is by multiplying both sides of the equation by the least common denominator. Okay, that will clear it out, but how do you do that? Let's talk about that. First of all, we got to know what the LCD is, right? As we get into the first problem here, we got to know what it is. So looking at this first problem here, let's go ahead and review what the LCD process is. But you can't do that until you review factoring. And so, again, if you look at that prerequisite review packet, it talks about that. Let me just pull that out here, the factoring discussion. Again, let me know if you have any questions about this. I'm going to kind of go through this here briefly. Whenever you factor any polynomial, you always factor out the GCF first. Okay. Let me know if you have any questions about how to find the GCF if you need to review that. But you always do that first. Okay. And then after that, it depends on how many terms you have. If the GCF is equal to 1, though, you can skip the first step usually. Okay. But if it's not, you got to factor that out first, very important. And then after that, you then look at how many terms you have, and then that'll tell you what method you do on the next step. Okay, so let's try that. Okay. On x plus 1 right there, and the reason why I'm looking at x plus 1 is because we need to find the least common denominator. And so we need to factor the denominators, not the numerators. Don't worry about those. Okay, but the denominators. Remember, the denominators are the things on the bottom. The numerators are the thing on the top of the fraction. But when you have something that you're factoring and the GCF is equal to 1, which it is with x plus 1, and on top of that, and remember what I just said, after you determine that the GCF is 1, you can skip the first step, move on to the second step. You'll notice, as we reviewed polynomials before, that x plus 1 has 2 terms in it because of the plus separates it into 2 parts there. If you've got 2 terms, then what we usually use, at least for now, is this formula. But if that formula does not work, you guys, and it won't here, because anytime you have x to the first power, or any variable to the first power, it could be y to the first, any variable to the first power, and you've got 2 terms, that can't be factored because that exponent, x to the first power, is too small for these exponents right here, 2 and 2. And so here's the thing. If you've got a GCF of 1 and you have 2 terms there, then that means you can't do the second step either, like I just said. And so if you've got a GCF of 1 and it's got 2 terms with x to the first power, okay, first power, too small of an exponent, that means that this is prime right here. And I'm going to go ahead and underline that because that's what we reviewed at the end of the last video. When you factor, you underline your factors. So we'll go through that more here again in just a second. Anyway, when you have, as I move on to the next one, and that's just prime, okay? That's just prime, meaning you couldn't factor it at all. And so that's when you have more than one term. and you can't factor it all, we call that prime. When you have a single term, then that is just, you can't factor that either. Okay, some people try to factor that in a certain way, but according to how I do it, I don't factor that. I just make that into one factor right there, no matter what kind of single term it is, whether it's x or if it's 3x or 5x. A single term denominator, and we just call that a single factor there as well. As I reviewed at the end of the last video, when you have just a single term factor, that's a green one. You don't have to use colors if you don't want to. I'm just doing that to make it easier to explain on the video, but you don't have to use the colors. When you have more than one term as a factor, and this is just one factor because we were not able to break it down into two or more factors because it was prime. But if it's got more than one term in the factor, we make it red. And again, we'll see why why the red and green once again is important in a minute. How about this one though? This one does have a GCF, so we need to factor it out. The GCF is x. Again, let me know if you need to review how to find the GCF. Okay. And so if I factor that out, I get x plus 1 left over. And once again, the x plus 1, as we already determined, remember what you do after you factor out the GCF is you figure out how many terms you have left over. And that's what I'm talking about there is what's inside the bracket. Since there's two terms inside the bracket, again, we look at the two-term rule. We try to use that, but as we said, x to the first power is too small of an exponent for that formula right there, okay? And so therefore, that's going to be prime. You can't factor it, okay? Sometimes you can take a bracket and break it down into two brackets like right here. We saw that last time in the last video, but not here because it's x to the first power and it's two terms. So when you have a GCF times just one bracket that doesn't break down to two brackets, that's a green and a red, okay? Green because that's a single term being multiplied by a bracket that has more than one term in it, and that's why the bracket is red. It's got more than one term in it. Okay, how does this all help us now that I've factored everything? How does that help me find the LCD? Okay, well, let's review LCD here real quick. LCD, what you do is after you factor everything and you underline your factors, this is from the prerequisite review packet, you underline your factors. What you do is you find the least common multiple of the single term factors. Okay, and it reviews here how to do that in a normal situation, but I will tell you in this particular situation that we're looking at right now, notice we have only two green factors. And they're both the same. When that happens, the least common multiple, which is what they ask for after you factor everything, the least common multiple just of those two single-term green factors is going to be the same thing because they're the same. Okay, if they're both the same, then the answer there for that step, the second step of the LCD steps, would be just to make it the same thing. Okay, so if this had been 3 and 3, then you would say 3 is the answer for that step. Okay, but since it's x and x, we say x. Then the last part of the LCD process, it says list each of the different multiple term factors. Those are the red ones. Okay, notice it says there, very important, different ones. Okay, so we have a total of two multiple term factors, two red ones, right? But there's only one different one because they're both the same. Okay, so if these two red ones had been different, I would put them both in the answer. But since they're the same, and since it said to just put all the different ones in there, I am going to just put that in there once. Okay, do not put that in there more than once. There's one exception to that, which you don't need to worry about right now, but usually you just put all the different ones in there one time each. Okay, so just list out x plus 1 once. Again, if there was a different red one other than x plus 1, you'd put that in there as well. But since both of the red ones are the same, you just put in x plus 1. And that's it. You do the green part, you do the red part, you've got your LCD. Now we're on our way. Okay, how do you multiply both sides by the LCD? You do that by, very carefully here, if you've got two fractions on one side, you could either have a plus or minus in between it, doesn't matter which one. What you do is you multiply both of them by the LCD, but you got to be real careful here to not do it too quickly. I know this is going to involve more writing, but it's worth it. Okay, you want to write down the LCD and put a 1 underneath it, because whenever you multiply by a fraction, you want the LCD to be a fraction also. So make it into a fraction by putting it over 1. Okay, multiply by the first fraction there, bringing that down. Then you bring down the plus in between. So I've got the LCD times the first fraction, bring down the plus. Then I'm going to do the LCD again times the second fraction, 2 over x right there. Then bring down the equal sign, and then if there's only one fraction on the other side of the equal sign, then just multiply the LCD by that. And put the denominator in its factored form. Don't leave it as x squared plus x anymore, because we're going to need the factored form in order to do what we're going to do next here. Okay, so whenever you factor a denominator, keep it in that factored form here on the next step here, because you're going to need to factor it anyway. So might as well write it in its factored form that you already put it into. Okay, so what we have created here is we've created 3 multiplications. Most of these problems will have the 3 multiplications. Okay, but usually you'll have 2 on one side of the equal sign and 1 on the other. But that's what you do when you have 2 fractions separated by a plus or minus. You're going to have 2 multiplications, okay, with the plus or minus in between. All right, and then the other side just had the single fraction. You just multiply by that. Okay. Here's what you do. In these 3 multiplications here, these 3 things that I circle, we need to review real quick, how do you multiply fractions together? I'm not just talking about little fractions. I'm talking about the big fractions with polynomials and variables and stuff. Okay. Review, if you look back at the prerequisite review packet again, it talks about how you need to factor everything. You see I factored everything here. I underlined the factors. All right. And then I cancel what I can, and I'll review that with you as well. Okay, so doing that, all right, and I'll keep this handy here that we can look at it here. But remember, let's take a look at our factors here. Most of the stuff is already factored. Okay, 4x plus 3 is factored. The LCD should already be in factored form already, assuming you don't change it from the way we originally wrote it down here. Okay, so that's factored. Okay. This is prime because it's got a GCF of 1 and it has x to the first power with 2 terms. Remember, x to the first power with 2 terms, that's already prime, as long as the GCF is also 1. Okay. This, as we already determined, was prime. Can't factor that. We know, because this is a green and a red up here. All right. We know that this is green and red here. All right. The green and red thing, whether you write down the green and red colors or not, it is important to understand. It is important to understand what's green and what's red, because that tells you what you're allowed to cancel and what you're not allowed to cancel. Okay. Before I start canceling, let's do it on the other 2 here as well. Let's identify our factors. Okay. This again was prime. That means it's just a single red one because it's got more than one term in it. These are all single terms right here, the 2, the 1, and the x, okay? And so that's why, just like I did with the x up here, a single term in a numerator or denominator, that's just a single green one. Last one here, we know that x times x plus 1, that's a green and a red. Okay, anytime you got a GCF times a bracket, assuming that you've factored it as far as it'll go, the bracket is prime, so we did. That would always be a green and a red. And then the 1 and the 1 are just single term numerator denominator, so those are just green. Why am I doing the green and red now? Just to review here. It's because you're only allowed to cancel red and red. Okay, you can't cancel a red one with a green one, for example. So you can't cancel the 1 and the 1 here. You can't do red and green together. You can do green and green together, but you can't do red and green together. So I'll get to the green thing here, reviewing that in just a minute. But notice here that these 2 are the same. When you're canceling red and red, it has to be exactly the same. Okay. There's one exception to that, which again, you don't need to worry about that right now. Typically, when you're looking at red one on top, Okay, it could be in the opposite fraction. You can cross cancel when you're multiplying, not when you're adding. So I cannot cross cancel this red one and this red one because we're adding here. But when you're multiplying two fractions, you can cross cancel as long as what? If they're both red but they're exactly the same, you're allowed to cancel it. If that had been x plus 1 and x plus 2, you wouldn't be able to do it. And no, you wouldn't be able to do the x's either. You can't do part of a red one, okay? It's got to be the whole thing or nothing at all. And it has to be exactly the same as the one below it. Okay, so a little review there. That's the only thing I can cancel though, right? Because all I have left on the bottom is 1 and 1 now. When you cancel two red ones that are the same, it becomes 1 and 1, always. And so all I have left on the bottom is a 1 and a 1. You can never cancel 1, okay? 1 is pretty much simplified as far as it's going to go. And so we're done there. What does this leave me with here? It leaves me with here x times 1 times 4x plus 3. Remember, when you multiply fractions, you multiply across the top and across the bottom. You got x times 1 is x, but then x times 4x plus 3 looks like this. Don't multiply it out yet. You might be wondering, why did you put that in brackets, Mr. Wakefield? It's because whenever you multiply something by something that has more than one term in it, you got to bracket that thing that has more than one term in it. And by rule, when you multiply a fraction times another fraction, you have to multiply by the entire other numerator here. The entire first numerator times the entire second numerator. Okay? And so if one of the numerators has more than one term in it, you got to bracket that numerator when you multiply it. Okay, that's why I'm not multiplying this yet. I'm just writing it like this. I will multiply the x through the bracket on the next step. I want to be careful not to do too much here to avoid mistakes. All right, but you got to bracket that when you multiply by a numerator with more than one term in it. Bring down the plus now. Okay, then we cancel what? We're allowed to cancel green with green as long as they don't even need to be the same, okay? You just cancel the same way that you would cancel, say, a single term over a single term. I know it's hard to see this here. Let me write it down the way it was before I did all the canceling. Again, this is from the review packet. If you got a single term over a single term, you can cancel the way you normally would with coefficients and if the variables are the same and all that. But if they are the same, though, like x and x are, then you can that just becomes 1 and 1. Just like when two red ones are the same, if two green ones are the same, you can cancel that. That's 1 and 1. Otherwise, it would be similar to this right here. You would cancel like this. Again, let me know if you have any questions about that. But right here, with x and x, it's just 1 and 1 because they're the same. What are we left with here? We're left with 1 times x plus 1 times 2. 1 times x plus 1 is x plus 1. Times 2. Recommendation here, though. Notice that 1 times x plus 1 is x plus 1. That's still two terms right there. That's still two terms. So you got a two-term numerator times a one-term numerator. Whenever you have that, please put the one term in front and make sure the two-term numerator is in brackets still, because, like I said, when you're multiplying by a numerator with more than one term in it, you got to bracket it. Okay? If I just wrote it like this, you guys, that would be wrong right there because it looks like you're just multiplying 2 times x. No, you're supposed to multiply 2 times the entire thing, x plus 1. So don't write it like that. Write it like this because the x plus 1 has two terms in it. Okay. By the way, on the bottom, it's 1 times 1. That's why I didn't write a denominator here. 1 times 1 is 1. And you know that when you have a denominator of 1, you don't need to write it. Okay. Because it's just like saying 8 divided by 1. 8 divided by 1 is just the same thing as 8, right? So you really don't need to write the 1. And so that's why I don't write that. And that's what it's did. Remember I said at the beginning of this video, I said that we're trying to get rid of the fractions by doing the LCD step. Well, we're getting rid of them because the bottom is 1 times 1. On this last one here, same thing. We can cancel the x's. They're both green. Remember, don't do red with green, but you can do green with green, and you can do red with red, like that. And they're both exactly the same. That's why I'm allowed to cancel the reds. And so what am I left with here? I'm left with nothing but 1s, right? 1 times 1 times 1. 1 times 1 times 1 on the bottom as well. And so that's 1 over 1 is the answer. And we know that 1 over 1 is the same thing as 1. What I've created here, you guys, by getting rid of the fractions is I've now created, you're going to end up with one of two things when you do these problems and you get rid of the fractions. You're going to end up with either a linear or a quadratic equation. Okay, right now it looks like it's linear because you don't see any x squared terms, right? You don't see that x to the second power thing that we saw with quadratics. However, if you distribute this out, if you distribute out these parentheses, which is what we learned to do with the linear equations and also with most of the quadratic ones, if you do that here, thinking that this might be linear, or at least it looks linear, what you end up finding out is when you distribute it out, you end up seeing a 4x squared pop up, don't you? Okay, so in reality, something's quadratic if you get rid of the parentheses and you have a polynomial on both sides and you have a x to the second power. Okay, after that, that's when it's quadratic. And so the fact that we hadn't got rid of the exponent, or I'm sorry, we hadn't gotten rid of the parentheses yet until this step, okay, that's why we really didn't know if it was linear or quadratic yet up here. It's because the difference between linear and quadratic is based on when you get rid of the parentheses, what happens in that case, what is the highest exponent? Well, getting rid of the parentheses here, I found out that 2 was the highest exponent. So in reality, it's quadratic, even though it looked linear at first. Since it is quadratic, we learned in the last video that we have a choice of one of 4 different methods depending on what we got. Okay, remember I said that you have the choice here unless the problem tells you have to do it a certain way. We talked about that in the last video. Okay, well, in my opinion, and again, it doesn't have to be the same as your opinion because you have the choice, just as long as you do a method that works, okay? But in my opinion here, this is one of those problems where you want to move all the terms to one side and then try to factor it. And if the factoring does not work, then you can then try the quadratic formula. Again, that's all what we talked about at the end of the last video. So moving the 1 over to this side, also combining like terms. When you move everything to one side, you need to do that, as we talked about last time. We end up with this right here. Okay. So now I'm going to try to factor this. This is one of those factoring ones where we do the 3 terms right here, right? Okay, where we do the Berry method when it's the 3 terms and it's got the x squared and then the x and then no x at all, as we talked about it and we reviewed in the last video. Okay, so we did what? We did 4 times 1 is 4. And then we said, okay, what 2 numbers equal 4 when you multiply them, but they add up to 5? Wouldn't that be 4 and 1? Those same 2 numbers? 4 plus 1 is 5 in the middle, but it equals 4 when you multiply these 2 numbers. So doing the Berry method, and again, you could do a different method as long as it produces these 2 brackets, if indeed it does factor. If something does factor, and if it doesn't, you can always do the quadratic formula. But if it does factor, you could do it however you want. You don't have to do the Berry method, like I said. Just make sure you do a method that does work. All right, but what do we got here? We got 4x and 4x for 4x squared. All right, and then you put these 2 numbers in there, just like we said last time. But we still got to factor out the GCF out of these 2 brackets if there is any. This one has a GCF of 4, so if I factor that out, and discard that GCF, which we always do at the end of the Berry method, we get x plus 1. The other bracket has a GCF of 1, so that does not do anything then, as we talked about last time. And so our factoring ends up being equal to that right there. And we learned last time as well that we reviewed that when you factor and you just end up with 2 brackets that have 2 terms in it like that, that's 2 red ones right there. Okay, and we set both of those equal to 0, and we get what? This right here, right? And then solving those 2 brand new linear equations that we just created, I subtract the 1 over to the other side. That's what I'm doing here. I get -1. Here I subtract the 1 over to the other side, but I also got to divide out the 4 to get the x by itself, right? And that gives me negative 1/4. Now, with fraction equations, you guys, and a lot of people forget this. Please be careful not to forget. When you have a fraction equation, you need to check your answer. It's not enough just to get x by itself. Don't just move on to the next problem. Okay, you got to do that last thing here where you check. But you don't need to check the entire problem. You just need to check the original denominators that you had. Okay, negative 1. What you do is you plug it into the denominators, all three of them, and if any one of them is equal to 0, then that's not an answer, because you can never have a 0 denominator. Okay, when you divide something by 0, which is what it means when you have a 0 denominator, you're dividing by 0. There's no answer for that. Okay, dividing by 0 is impossible. Okay, if I say what's 3 divided by 0, there's no answer for that. And so there's no way it could be a solution then if there's no, because remember, solutions are something that makes the equation true. Okay, if a number doesn't even make an answer, it can't make the equation true then. And notice negative 1 right here. If I plug it into here, what is negative 1 plus 1? Isn't that equal to 0 right there if I plug that in? And so that makes the negative 1 makes the first denominator equal to 0. You don't even need to check the other denominators, because if it makes any of the denominators equal to 0, I need you to cross that out, okay? Cross that out. But let's check this one now. Negative 1/4 plus 1, okay? Does that make the denominator equal to 0? Now, I don't care what it's equal to. You don't even need to figure it out. Just understand that when you have a negative plus a positive and you're adding, negative plus positive, the only way that that could be equal to 0 is if these were opposite numbers of each other. In other words, if you had like negative 1 plus 1, or negative 3 plus 3, or negative 4 plus 4. If the numbers are opposite, negative 1 and 1, negative 2 and 2, negative 4 and 4, that's when it would be equal to 0. 1/4 and 1 are not opposites of each other. So there's no way that this is going to equal 0. Okay? Negative 1/4, if I plug it into that one, it's not going to be equal to 0. It's just equal to negative 1/4 because there's just the variable there. And then if you plug in negative 1/4 here, I get, if I square it, I get 1/16. And then if I plug it into the x, I get 1/4 there. Okay, because it says to square it and then add it to the same thing. I'm sorry, I wrote that down wrong. That should be minus 1/4 because we're plugging in a negative there. Plus negative 1/4. So again, what you're doing here, in fact, I'll write it down exactly as it's written, even though it's the same thing as minus. It's 1/16 plus negative 1/4. And once again, if you've got a positive and a negative, the only way that's going to add up to 0 is if they're opposites of each other. You know, like negative 1/4 and positive 1/4. Just like I said earlier, negative 1 and 1, negative 2 and 2. So this is not going to add up to 0 either. So this one is good. It does not make any of the denominators equal to 0. All right. Okay, so let's review here before we try these other problems. Okay, we got what? Since we have a fraction equation, we're going to multiply both sides of the equation by the LCD. Okay, if you got two fractions with a plus or minus in between, all right, you multiply both of them by the LCD. Put in that plus or minus in between. Okay, you do your canceling. All right, you get either a linear or quadratic equation, and then you use the appropriate method based on what you have. Okay, don't forget to check your answers though. Cross out the bad ones like I did with the negative 1. Keep the good ones like the negative 1/4. Let's try that again now. In this next one here, again, we have to, since we have a fraction equation, we have to factor our denominators. These are both prime. Okay, just like the x plus 1 was prime earlier, so is the x minus 1. Okay, because of the fact that the GCF is 1 and it's got two terms with x to the first power in it. That's automatically going to be something that you can't factor when you have two terms in x to the first power. But look for the GCF first, okay, because there still might be a GCF, but not in this case, so I'm just saying. Okay, x squared minus 1. That has a GCF of 1. However, that fits, x squared minus 1, that fits into the a squared minus b squared thing, because it would be x squared minus 1 squared. X squared minus 1 squared. okay, is equal to x squared minus 1. All right, so if you have, it's no different than if you had x squared minus 9, it would be x squared minus 3 squared. If it had been x squared minus 16, just to review with you real quick, then it would be x squared minus 4 squared. All right. Same idea. Okay. Now, so this would be what then? If it's x squared minus 1 squared, then the rule is like this. Let's follow it here. X squared minus 1 squared would be x minus 1, x plus 1. Okay. If it had been this right here, x squared minus 16, that would be x squared minus 4 squared. That would then be x minus 4, x plus 4. Okay, so a little review there. Okay, but here it would be what? It would be x minus 1 and x plus 1. Like that. Then, that's two red ones, isn't it? Two red ones. What is the LCD? Well, we learn it with the LCD after you factor everything, okay, and you identify your factors. Again, these are two red ones because it's two brackets with more than one term in it, so that makes them red when they got more than one term. But notice there's no green ones this time. So unlike over here where I had to do the green part, you can skip that step and just go right to the red part. The red part is the part where you write down all of the different ones in there. There's a total of 4 red ones, isn't there? But there's only 2 different red ones, right? Okay. There's only 2 different red ones, x plus 1 and x minus 1. So that's all that you put in the LCD. Keep them in brackets because they're supposed to be multiplied together inside the LCD. And like I said before, if you've got something with more than one term in it and it's being multiplied, okay, by something else, you've got to bracket it. So yeah, keep them in brackets because they've got more than one term in it and they are being multiplied by something else. Okay. All right. So we're going to multiply. So multiply this LCD right here by how many things? Well, just like in the last problem, we have we have 2 fractions on the left-hand side with the minus in between this time. So bring down the minus in between. We got the LCD being multiplied by the first fraction. Bring down the minus. We got the LCD. We need to multiply the LCD by the second fraction. All right. Bring that second fraction down. Put the LCD over 1 because we're multiplying it by a fraction. Whenever you multiply something by a fraction, you want to make that other thing that you're multiplying by into a fraction as well. Okay. Pardon me here. I'm running out of space here a little bit. Oh, I can squeeze it in here though. I know it's kind of hard to read there, but that is those 2 brackets right there are x plus 1 and x minus 1, just like the x minus 1 and x plus 1 here. I wrote it in a different order there, but it really doesn't matter because when you multiply 2 things, it doesn't matter what order you're writing those 2 brackets in. But just to keep it the same as the way it was written, I'll go ahead and rewrite it there. So that's x minus 1 and x plus 1 from here. I just brought it down with the negative 2 right above it. Let's start taking a look at how to get rid of these fractions now, because that's why we're doing the LCD thing. It's so that we can get rid of these fractions. What do? Well, these are green, like I talked about in the last problem when we reviewed that, because they're just single term numerator and denominator. Whenever you got 2 brackets being multiplied together and that's it, that's 2 red ones. Okay, and then this is just a prime multiple term polynomial on the bottom, so that's just a single red one like we've said before. Same thing here, these are 2 red ones. This is just a single red one because it's prime, and then these are just green. Again, this red and green thing is important again because it tells you what you can cancel and what you can't, because you don't want to cancel the wrong thing in the wrong place. That'll ruin the whole problem. Okay, so knowing what all my red and green ones are, you guys, what do? We start canceling. One one thing at a time. Let's start out with this circle here. I can cancel the x plus 1 and the x plus 1. Remember what I taught you earlier, though. All I got left, other than the 1s, and you know that when you multiply by 1, it doesn't really do anything. You got 1 times, so we can ignore that. But then we have this 2-term thing being multiplied by the single term. Remember I said over here that when you got 2-term thing being multiplied by a single term thing in the other numerator, and that's all you got other than the 1 right here, put the single term one in front. Don't multiply it yet. Just say that the single term is being multiplied by the x minus 1. Okay, we want to make sure we don't go too fast here and make a careless mistake here or something like that. Bring down the minus after that. Okay, and then here I can cancel these, right? Remember, they got to be exactly the same, so don't cancel the x plus 1 with the x minus 1. Okay, those two would be almost the same, but they're not exactly the same. Those become 1s, and now all I have left on the top, other than those 1s that I created there, is this single term times this multiple term one. And I know that's a 1 also, but still, let's stick with the same idea here, since that's the entire numerator. If you've got a numerator with 1 term in it, and you've got another numerator, not including the ones that you created when you canceled, that has 2 terms in it, put the single term in front of the multiple term one and keep the multiple term numerator in brackets. If it's not already in brackets, put it in brackets. Okay, this was already in brackets, so that's fine. And please, you guys, the biggest mistake students make is they try to distribute the 1 now instead of doing it on the next step. That's a big mistake because you need to distribute the minus with the 1. And a lot of people will forget to do that, and it'll ruin the problem. Okay, so don't distribute yet. All right, bring down that single term and the multiple term behind it. Like I said, bring down the minus in front of it. Then if you distribute on the next step, it'll work out correctly. Okay. Over here, both of these cancel, don't they? The x minus 1 and x minus 1, the x plus 1 and the x plus 1. Okay, they both cancel. Everything becomes 1s, okay, on the red ones anyway. All we have left is 1 times 1 times negative 2, which is, of course, negative 2, right? And there you go. And so we did it. We got rid of the fractions. It now looks like a linear or quadratic equation again, right? But we don't know which yet. Well, if I distribute this out, even though it looks like it's linear right now, once again, it's going to become quadratic, isn't it? It's going to become quadratic. All right. So let's take a quadratic strategy here. Now, normally, I would be like, hey, I got all these terms. Let's move them all to one side. But notice that these terms are going to cancel when I combine like terms, right? So this is one of those problems where I just have an x squared term, but then no other x terms. So that's the one where, let me remind you from our previous video, when you have just an x squared term and then all the other terms don't have any variables in it, that usually means you can do the square root property. Okay, so that's what I'm going to do here. You can do something else as long as you're able to get the right answer, but I would recommend that here. And the way I'm going to do that is, just like I did in the last video, I'm going to highlight the x squared here. Not the negative, but just the x squared part. And I want to get that by itself. The way I can get that by itself, since it's negative, I can move it over here. Okay. But then I still need to get it by itself by moving over the 2 to the other side, right? And that gives me, let me move it up here. That gives me 1 equal to x squared. Once you get the x squared by itself, with no variable on the other side, just like right here from the last video, you do that double square root thing. Let's do that here. So I get what? I get x is equal to either square root of 1 or negative square root of 1. Okay, and then you simplify your radicals. But if the radical has a what we call a perfect square underneath it, you know, like 1 or 4 or 9 or 16, one of those numbers where you know the square root, then just go ahead and just figure out what the square root's equal to. So that would be 1 and negative 1 because the square root of 1 is 1. And the negative here makes that negative 1. So we did it. We got the x by itself, but you got to remember to do what, you guys? You got to remember to check your answers. Okay? Check your answers after you get x by itself. All right? But look at what's happening here. Okay? If I plug in the 1, even though this one would be equal to 2, 1 plus 1 is 2, if I plug in the 1 here into the x, I get 1 minus 1 is 0. Oh, so that one's bad. Remember, if it makes any of the denominators equal to 0, you got to cross it out. But look at what happens with this one. This one's also bad. If I plug in negative 1 here, I get negative 1 plus 1. That's also 0. What happens when they're all bad? You get, no matter how many answers you get, if they're all bad, what do we say is our final answer? Well, if you have no good answers left, we say no solution. Don't say no solution if you actually have an answer that's good. But if you have no answers that are good, you have to say these two words, you guys. You can't just cross these two out and then move on to the next problem, because then I'll be wondering if you understand that there really is no solution, as opposed to maybe a situation where yeah, these two numbers aren't the answer, but maybe there's another answer hidden somewhere else. I guarantee you there will not be another answer hidden somewhere else, okay? If you get your two answers using the method I showed you, okay, and not that it'll always be two answers, but however many answers you get using the method I showed you, and they're all bad, then you need to say those two words, because I will guarantee you there's no hidden answer somewhere. If the answers you got are all bad, then that means that there definitely is no good answer anywhere. No hidden answers here, okay? As long as you use this method, there won't be any hidden answers. So you just check the ones you got, get rid of the bad ones, keep the good ones, and go ahead and circle the good ones. If there are no good ones, you say no solution. Okay, one more to go here. Figuring out the LCD, we know that when you have just a single term as a denominator, that's just a single green one. We already know that x plus 1 from the previous two problems is a prime polynomial, so that since that's got two terms, it's red. Whenever you have, just to make it simple, without going through the whole LCD process here, let me just tell you right now, if you only have one green one and one red one, and that's all you got, just one green one and one red one, I guarantee you the LCD is just going to be those two things together. Okay, no use in going through the whole process of figuring it out. If you've got one green one and one red one, and that's all you got, then the LCD will just be those two things together. Again, keep the red one in brackets because it's got more than one term and you're multiplying it by the 4. You have to multiply the different parts of the LCD together. And so that needs a bracket there. Okay? But that's what you do in that case. Now, what do we always do once we find the LCD? We multiply the LCD by the three different parts here. It's usually going to be 3 parts. Again, on the left-hand side, I know that's not two fractions like it was in the previous problems, but when you have a fraction and then just a regular term, it's still the same idea. You multiply the LCD by that fraction, you bring down the minus that's in between, and then, like I showed you, actually it doesn't matter here, you don't have to do that, if it's just a single term, you don't need to make the LCD, you don't need to put the LCD over 1 in this part, because the whole reason why I put the 1 underneath the LCD in those other parts of these problems that we've done is because you were multiplying by a fraction. Well, this time you're multiplying by just a term, okay? So we just say the LCD times the x, bringing down the minus in front of that, okay? But you have to multiply by the x, you guys. Don't think that the LCD is only supposed to be multiplied by the fractions. It has to be multiplied by the entire left side of the equal sign and the entire right side. So if you've got a term and a fraction separated by either a plus or a minus, you can't just ignore that term that's not a fraction. You've got to do that one as well. Okay? So don't forget that. Okay. Now, And then, of course, we do the other side as well, just like we've been doing. So we identify our factors here. This is prime because it's got a GCF of 1, and then it's got 2 terms with x to the first power. That's going to be prime then. So that's just a single red one when it's prime and it's got 2 terms. Whenever you got a single term times just a single bracket with 2 terms in it, that's our green and a red all the time. We've seen that already. Okay, so let me just identify. You don't need to do the red and green here because we're not canceling. No canceling here because there's no fractions. I'll talk about how to handle this in a minute. I know it looks kind of weird, but we'll get through that. Okay, let me just look at these other ones here first. Okay. So that's red and green right there. 2x and 1 are green because they're just single term numerator denominator. That's a prime, so that's red. Let's look at the first one here. Remember, you're allowed to do green and green as long as they cancel. And 4 and 4 cancel with each other. Nothing else cancels though, right? Okay. And so this is one of those rare situations where we have a red and another red because both of the numerators still have 2 terms in them, not including the one that you created. Remember, you can ignore those. Okay. And so I put them both in brackets because they're, again, got more than 1 term and you're multiplying them by each other. 1 times 1 on the bottom, so you don't need to write that. Then you bring down your minus. Now, how do I handle this? Well, let's talk about this carefully here. When you got a single term times a bracket, but then you multiply that whole thing, which is what you're supposed to do, you multiply that whole thing by another single term. Here's how you handle that. Okay, ignore the minus. Don't do that yet. Okay. What you do is you take the 4 and the x, and you multiply those first. That would be 4x. Then you now need to multiply that by the bracket. Don't distribute it yet. Remember, we wait till the next step to distribute it. We want to make sure that minus gets included. But when you have a term times a bracket times a term, you can do the 4 times the x without doing the minus yet. Bring that down, and then we'll distribute on the next step. Okay, that way you now have just a term times a bracket, and you can do the normal distributing on the next step. But I wanted to combine that 4 and the x together first. Over here, the only thing that cancels are the 2 red ones because you're not going to cancel anything with the 1 here because the 1 doesn't, you can't reduce a 1. Okay, so the purpose of canceling is to reduce it down to something smaller. Okay, and the 1 can't be reduced to anything small. So what do we got left, not including the 1s here? 4 times 2x. Single term times single term, you can go ahead and multiply that right now. I just want you to wait when you have when you're multiplying by something that has more than 1 term in it. That's when I want you to just bring it down, put it in brackets, and wait till the next step to distribute it. But if you have a single term times a single term, not including the 1s, this just becomes a 1 right here. So that's no longer a bracket anymore. It's just, I mean, the bracket is still visible there, but it's just a 1. So if a bracket just becomes a 1, you can ignore it like any of the other ones that you create when you cancel. So it's just 4 times 2x, and that would be 8x. Okay, so what we got is we need to finish this off. Again, it looks linear because you don't see any x squared terms, but if you multiply these out, okay, it's going to be quadratic, as you're going to see here. All right. As we reviewed at the very end of the 1.4 video, when you got 2 terms in each bracket here, the way to distribute that out is to multiply 4 things here. Okay, x times 4x, x times 3. Do the inside terms next, 1 times 4x, and then the last terms are 1 times 3. Then we distribute the negative 4x. Okay, remember you got to distribute the negative along with it here. That's why we got to be so careful. Minus 4x squared minus 4x equals to 8x. Now you can see that it looks quadratic, doesn't it, because of the x squared terms. But it looks quadratic right now. Okay, I don't blame you if you're thinking that. But it's actually not quadratic because sometimes something that looks quadratic, what happens is that sometimes, including in this problem here, the x squared terms cancel when you combine like terms. Okay, and that's the thing. The reason why I'm combining like terms is because normally when you have this situation, you look at it and you say, oh, it's quadratic because I see the x squared terms. I'll move all the terms to one side. And then you're supposed to combine like terms when you do that, right? Okay, but when we do that, they're going to just go away. The x squared terms, that is. And so now I'm going to shift gears here because I now realize it's linear because there's no x squared terms in it. And so what do we do in a linear equation? Well, we keep the x terms and the other terms that don't have x in it on opposite sides. But we do combine like terms after we distribute out the parentheses. So I'll go ahead and do that right now. 3x, 4x, and negative 4x equal 3x. 3 doesn't combine with that. And then we have 8x. Okay. Then in a linear equation, we move the x terms to the opposite side of where the non-x terms are, like 3. And that's why I'm moving the 3x over with the 8x. And then it's now time to divide out to get the x by itself. Again, it's a linear equation now. The 5's cancel. We end up with x equal to 3/5. What's that last thing I got to do, you guys? I've got to check my answers. Okay. Now, when you have a denominator with no variable in it, you don't need to check that one because there's no place to plug it in. Okay, that's a constant number there, no variable. It's always going to be 4. That means it's never going to be 0 because it's always going to be 4. We just need to make sure that the denominators are not 0. So that's fine. If I plug the 3/5 into here, what is 3/5 plus 1? Well, again, we don't care what it's equal to as long as we're certain that it's not equal to 0. We know, though, you guys, that when you have a positive number like 3/5 plus another positive number, that can never equal 0. A positive plus a positive can never equal 0 ever. Okay? It's just whenever you have a positive plus a positive, it will always equal an even bigger positive number, but it won't ever go back to 0. Okay? And so we know that that's not 0. You don't even need to figure that out. Just as long as you know that it's not 0, then you can be certain that this is something that you can circle instead of cross out because you know that it doesn't make this denominator equal to 0. And we already know it doesn't make that one equal to 0 either. Remember, you don't need to check this minus x in the middle because that's not a denominator because there's no fraction there. It's just the denominators that you have to check, just the bottoms of the fractions, in other words. So that concludes this first part of section 1.6. We'll see a couple other different types of equations in some succeeding videos we have coming up for section 1.6. But for right now, you have a good day. You take care, and we'll see you back here for that second video for section 1.6. And don't forget, I'm always available. If you have any questions, let me know. Take care.